Okay, so let's read this problem carefully before we have this discussion in class. Two jets leave San Francisco at 8 a.m., one flying south to LA, and at a speed 40 kilometers per hour greater than the other, which is traveling north to Sacramento at 10 a.m. Planes are 2,480 kilometers apart. Find their speeds. Okay, based on this problem, did I give you anything about the speed of the two jets? The exact speed, like this jet is going at this speed. Did I ever say anything like that? No. But did I give you some clues about the speed? Okay, so when you read the problem, you got to start making, mental notes of what's in here. And also, it's important. Certain skills I need to teach you, and I think it's important enough. But you need to start taking notes as well, and draw pictures if you have to make the problem clearer. Okay, we know that we have these two jets leaving San Francisco. So what I would do, honestly, is to draw myself a picture. So this is the hub they're going to start going. This is San Francisco, okay? That's the hub. One jet going north, one jet going south. So this is the northern jet, and this is the southern jet. Okay? We know, based on the problem, that the southern jet is going faster. Is that true? The one's going south? How much faster? 40. Okay. Do you see why I have to draw the one going south, the arrow going south longer than the north? Why do you think I made that decision to make it longer? Right. It will cover more distance because it's going to go faster, right? So because of that, I can just say this. Okay, well, I know that the one that's going to LA is going faster, exactly 40 kilometers per hour faster. The one that's going to Sacramento, is going slower, but I don't know about the speed of that plane jet yet. What other information is given from the problem? Now remember, our job right now is to bring in as much information as possible into our picture here. And then we're going to go and analyze it once we have everything in place. What else is given from the problem? What do you think? This is a good time for us to reflect on the problem you just read. Yeah, time. What is it about time that's given in the problem? 2 hours. Where did you get that from? The only thing I read was they left at 8 a.m. and at 10 a.m. they were just miles apart, the kilometers apart. How do you get that information? How do you get 2? Huh? Okay, so both jets started at the same airport at 8 a.m. At 10 a.m., which is exactly how many hours later? 2 hours later, right? Good. At 10 a.m., they are exactly how many kilometers apart? 2,480 kilometers apart. So I know that information. We'll talk about 2 hours later, from 8 to 10. So, sometimes the information is not given directly, but you have to understand it. Okay? And actually interpret from the information given. So is this all that's given from the problem? Yes, right? Yes? Okay. What did the question ask you to find? Can you tell me? The speed. We don't know anything about the speed of this. Okay, so we don't know anything about the speed of this plane, that's this jet, so I'm going to mark it as a green R. And we do not know anything about the speed of this jet going south. I'm going to mark it as a blue R. Okay? So no speed given yet, and we do need to find what the speed is, because we need to find, I should say rate instead of this R, sometimes you don't know what it is. So because we don't know what their speeds are, what should we start doing right now to start the problem? What is it called? Define your variables. Very good. So let's define our variables. Help me please define the 2 variables. What should we say? Yes?
The jet going south.
Say it clearly, please.
The speed of the jet that's going north.
Okay, so you want to say x is the speed of the, can we just say northern jet? to indicate it's going north? Are we good with that? To make it short? And what else do we need to declare? Okay, so y is the speed of the southern jet, right? Okay, are we clear on that piece? On why I declare these two variables? Because I don't know the speed of either one, right? I look at my diagram and I realize, wait, I don't know the speed of either one, so therefore it's reasonable to declare two variables to represent the speed of the two jets. Now, immediately right after that, because I just declare two variables representing the speed, right? I need to talk about, wait, so if I just declare something about speed, I better have a speed equation, right? Is there anything about this diagram that tells you about the speed? What is it? What is it? Oh, wait. Oh, yeah, it did give you something. 40 kilometers per hour greater. So how do you take that information about speed to write our first equation? Notice how it says that the southern jet, the one that's going south, is going 40 kilometers per hour, 40 kilometers per hour greater than the one that's going north. How do you take that information and tie everything up to write your first equation? Yes?
Like how we did yesterday, y equals x plus 40.
Okay, you said y equal x plus 40. Does that make sense? The southern jet speed is 40 kilometers per hour greater than the one that's going north. Is that good?
Yeah.
And look at this equation. Everything is about speed, huh? And there we have it. So this is the part that I want you to explain. When you write an equation, you've got to explain that to us. It's like, okay, the reason I came up with this is based on the problem, it tells us this, and so when I read the problem, it makes perfect sense. The northern jet is 40 kilometers per hour greater than the southern jet. There we have it, our first equation. So now that we used up our speed, I cross it out and say, okay, I wonder what we have left over. We have hour, and we have the time left, and we have the distance left, right? So you see how I kind of plan this through and say, hey, whatever we used up, we just cross it out. Whatever we still have left remaining, this is where we're going to tie everything together to come up with a second equation. And notice that what we have left is time and distance. And remember, I told you that whenever we deal with problems like this, that we have to start thinking about this particular formula. Is that true? Distance equal rate times time. If we have time and we have distance, let's think about this for a moment. But we also know that our second equation has to have the variable we define. Is that true? The variable we define is about what? Speed. So if we have speed and we have time, what will speed time give us? What will the distance? The speed and time multiplied together will give us distance. So is it fair to say that if I assume I know the speed of the jet that's going north, times it by 2 hours, that will give me the distance that this jet traveled to the north, right? And it's fair to say that if I know the speed of the one that's going south to LA, times it by 2 hours, I will also know the distance of that plane, the jet going south. But then you say, wait, but we don't know the speed of either one. But don't forget, we have a variable to represent it. We don't need to know the exact speed. So with that in mind, what do you think we should do? Yes? Yes?
Shouldn't we have the 2 times x?
Oh, wait, say it again, please. Say it.
2 times x?
2 times x. What would that give you?
Speed of 2 hours?
What is speed times time going to get you? 2 is the hour, x is the speed. Speed times time will give you what? What is speed times time going to get you? Distance. Okay, so do you also agree that if this is 2 times x, that this is going to be 2 times y? This represents the distance of the plane going north. 2 times y represents the distance of the plane, or jet, sorry, going south. Look at the two distances. What can you relate about the two distances with the overall distance? Did they give you the overall total distance apart? So how can you actually tie everything together based on the distance? Yes?
2x plus 2y equals 2,180.
Exactly. There it is. The distance traveled by the northern jet plus the distance by the southern jet should add up to the total distance apart. Does this make sense? You see how I kind of use the information given to come up with the second equation? But notice that the second equation also have to use the variable that you declare. That's how it is. So you gotta have this mental image in your head. Say, I know I'm gonna have to use the speed again somehow. And what's given to me is the hour. Speed times time is going to give me the distance. And we know that we have a total distance of this, right? So the distance of the northern plane plus the distance of the southern plane is a total distance of 2,480. Okay, any questions on that part? Now that we have it, I wonder what we should do next. What do you think? What's the next decision here? Anyone? Here? Decide what? Which method? Say it out loud, please. Why? It's not lined up for once. Yes, you're right. And notice that don't we have y already solved for? So technically, isn't y x plus 40? So that means every time we see y, we can do what? Plug it in, right? Substitute. So can we just go and directly substitute into here? So if I have to rewrite my equation, don't you have this? Yes or no? Now what? Distribute, okay. So I'm going to distribute 2 times x plus 2 times x plus, is it 80? Equals to 2,480. And now what? Let's simplify. Okay, which is? Okay, combine like terms. 4x plus 80 equals to 2,480. Next step? Okay, subtract 80 from both sides. Gotta speak up, guys. Come on. 4x equals to 2,400. And last but not least,
600.
divided by 4. Yes. So x can give you
600.
600 what?
Kilometers per hour.
You gotta know what your unit, the unit that you're dealing with in the problem, right? You can't just like go back and define whatever you want. It is kilometers per hour. Oh, but wait a minute. If x represents a northern jet going at 600 kilometers per hour, then how fast did the southern jet go? Do you know that? How fast did it go? How fast did it go?
640.
640. Very good, because it clearly stated that the southern jet traveled 40 kilometers per hour faster than the one going north. And there we have it. We just found our speeds. Any questions so far? While we're on the same problem, I want to demonstrate something here, guys. I mean, I want to make sure you understand this too. That you can remember, we can always force our method, right? We don't have to go and solve using substitution. If I want to solve using elimination, I can. And the way that it works is it true that I can always move my variable back to make it line up if I want to? So let's say this, I want to rearrange my red equation to make it look like the blue one. Then which variable should I move?
X.
The x. How do I move that? Subtract it. So don't you have this? Is that true?
Yeah.
Why do I place the x in front?
To line it up.
Yeah, to line it up. Because if I write y minus x, they're not lined up, right? So I have to force it like that. So watch. I just want to show you that it works this way too. 2,480. What's the next step after this?
Find the LCM.
Even before that?
Choose a variable.
Yeah, choose a column. Which one?
Y.
Okay, sure. Let's choose y. If you choose y, what is the LCM?
2.
2. So which equation or both should I modify?
No, only the top.
Only the top. And how do we modify that?
Times 2.
Times everything by 2. So it's going to become negative 2x plus 2y equals 80. So the blue remains the same as 2x plus 2y equals to 2,480. I'm still focusing on the y, so what should I do next? Subtract, and I subtract this one column or above, or all?
Oh,
All of them. So watch what happened. What is negative 2x minus 2x?
4x.
Negative 40. Negative 4x.
Is it 4x or negative 4x? Okay, be careful, okay? The signs are important. And this is the part that I'm talking about. Let's assume now, I'm just playing, but let's assume that you have 4x over here. Assume. You solve this one. What is 80 minus 2,480?
Negative.
Negative 2,400, right? You divide it by 4, x, you got that negative 600 kilometers per hour. And you're right. This is the part where I say, check your solution. Is that reasonable? That's why you say, oh, wait a minute. You cannot travel negative 600 kilometers per hour. Okay? So in this case, although when you get up there in high school or college, they will have negative speed. But that negative speed doesn't mean it's going slower in any way. It just means it's traveling in a different direction. That's all. But it should be a negative 4, and that should be a 600 kilometers per hour, and you get the same exact solution as you can see. So using elimination. So once again, you can always force your method if you want to. It never has to be just one way to do it. If you feel that, hey, I like elimination, I'm just going to change it to elimination, sure, you can do that. And if you love a substitution, it's already in that form, then go ahead and use substitution. Any question on this problem? At all? Did I make myself clear on the information that we gather from the problem and how the process that I eliminate this once I'm done using it, and whatever left over, I use it to write my second equation? Yes?
Where did you get 2x and 2y?
Where did I get the 2x and 2y from? Remember we have to use elimination, I have to find the LCM. The LCM is 2, right?
Not that, the substitution part.
He means, how do you have 2x plus 2y equals 2?
Oh, this one right here?
Yeah.
Okay, let me ask you this question. Based on the problem, didn't we declare the x to be the speed of the Northern jet? And do we also know that they both spend 2 hours in the air?
Oh, okay.
2 hours times the speed will give you the distance. So notice the distance of the Northern jet plus the distance of the Southern jet will be 2,480 miles apart. You see it? So that's how I get the 2 from. Okay. Remember, yeah, I mean, it doesn't say they spent 2 hours in the air. The only thing that it says was they took off at 8 a.m. and at 10 a.m. So you see that it's a 2 hour difference. Okay? Any question on this one? Very good. So let's go back and actually take a look at our next problem here. We're on a roll, so let's get this done too.